In this lecture, we're going to learn about the typeid operator. And this is an operator we have in C++ we can use to ask a base pointer which kind of derived object it is managing at a given moment in time. So we can basically use this to pick on the dynamic type of a base class pointer or reference, and we're going to get that information to be able to print it out and see what is really happening behind the scenes. This is only going to work for polymorphic types. So if you don't have polymorphism going on in your inheritance hierarchy, this is only going to give you static binding results. And typeid is going to return the name of a dynamic type if it can, and if it can't, it's going to give you the static type that is a result of static binding in your inheritance hierarchy. So we're going to be exploring how this works in this lecture. Here we have a polymorphic inheritance hierarchy, and it is polymorphic because we have a bunch of virtual functions. In here you see in dynamic derived we are overriding the do something method and we are inheriting publicly. So because we have these virtual functions that we are overriding, this is a polymorphic inheritance hierarchy because we will have polymorphism going on for the do something method here. If we call it through a base pointer, we will get the most specific version called, and this is polymorphism in action. We will also set up a non-polymorphic inheritance hierarchy. We will have a base class, we will inherit from that publicly, and we will have a method which is really not going to override what we have in the base class. It is just going to hide what we have in base. And this is the setup we're going to use to see what happens if you use the typeid operator with a non-polymorphic inheritance hierarchy. Okay, enough setup. Let's see how we can use the typeid operator. We are going to start by looking at how this works with fundamental types, and this is how you use it. You say typeid, you pass your type in this parenthesis, and then you call the name method on this, and it is going to give you the dynamic type if it can find it. If it can't, it is going to give you a static type. So here we can use this to our advantage to really ask a type which kind of dynamic type it is. So for example, here we can say typeid 22 and test to see if it is equal to the typeid of int. If this is equal, we will know that 22 is an int. If the test here fails, we're going to know that 22 is not an int. And we will see these results printed out on the console if we try this out in a minute when we hit Visual Studio Code. I realize this is a silly example. Nobody would really do this in practice, but it is just an example showing you what you could potentially do with the typeid operator in C++. But it is possible to do even more useful things with the typeid operator. Here we are using our polymorphic inheritance hierarchy. We are going to create a derived object here, and we are going to set up a base reference, which is going to be referencing that derived object that we created on top here. Now, we're going to pass these guys in our typeid operator. We're going to pass the derived object and see what we get. This is going to give us a static type because we are using this directly on a raw object. This is going to give us static binding results. So this is going to give us a static type. But if we use a base reference and see what is pointed to or what is managed by this reference, we're going to get dynamic binding results. So this will be pointing to a derived object, or I should say this will be referencing a derived object, and this could give us dynamic binding results. So we will see a dynamic type printed out here. We will see that this is referencing a dynamic derived object. This is what we will see here, and this is the result of dynamic binding. I hope this makes sense. If you still think this is not clear, please bear with me. We're going to see this when we hit Visual Studio Code. It is going to become super clear. We can also use this with pointers. We can set up a base pointer, which is going to be managing a derived object in memory. We can print the type ID of the pointer directly, but this is not going to give us dynamic binding results because if you don't dereference the pointer, you will just get a static type of the base pointer here. But if we dereference the pointer before we pass it through typeid, this is going to give us a dynamic type. This is something you need to be aware of. So we can also try to use this on our non-polymorphic inheritance hierarchy. We're going to set up a derived object which is managed through a base pointer. We are also going to set up a derived object directly and set up a reference which is going to be referencing this derived object. We can also print the dynamic type of our reference, and we will see this printed out on the console. Now, if we try and pass our pointer through our typeid operator, we will get static binding results because we don't have polymorphism going on in this inheritance hierarchy here. The same is going to go for our typeid with the reference. This is going to give us static binding results, even if we are really using a base pointer and a base reference to manage derived objects. One thing I should tell you is that the type you will see printed out here is going to be different depending on which compiler you use. Compilers are free in setting up these things in different ways, but in most cases you are going to get a hint at the class name that you are using here. So we will see static base and static derived printed out to tell us that it is a base pointer or a derived pointer or a derived reference that we are dealing with, to know if we have static binding or dynamic binding results. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is typeid operator. We're going to grab our template files and put them in place pretty quick. We are going to put in the files that contain our polymorphic and non-polymorphic inheritance hierarchies. You can get these files from the resource section on this course if you don't want to type these things. And we're going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our code. We can look at our polymorphic inheritance hierarchy. We will have a dynamic base class. We will derive from that and create dynamic derived. And we will have a bunch of virtual functions, one in the base class and the other in the derived class, which is going to be overriding what we have in the base class. Nothing complicated here. We will also have a non-polymorphic inheritance hierarchy. This is going to give us a static base. We're going to set up a function. We're going to derive from this class and create static derived. And we're going to have a function which is exactly going to be like what we have in the base, but it is going to hide the implementation we have in base because this is not overriding. We are not using virtual functions here. We can head over to the main CPP file and include those two files. We can include polymorphic.h and we're going to include non-polymorphic.h. We're going to remove what we don't need in the CPP file here, or in the main function, I should say. And we are going to explore and see how the typeid operator works with fundamental types. For example, you can ask it if the type ID of 22 equals the type ID of int. And if this checks in, we're going to know that 22 is an int. If it's not, we're going to know that 22 is not an int. We're going to run this code and show you that it's actually going to work. We're going to pass this through GCC, our favorite compiler. The build is going to finish successfully. We can clear, or we can bring up our PowerShell window. That's much safer. And run rooster. We're going to see that 22 is an int. If we had 22.2f, meaning that this is a floating point, literal, we will see that this is not an int, and we will hit this block here and print 22 is not an int. We can try and pass this through GCC. For example, the build is going to be good. We're going to clear and run rooster. We're going to see that 22 is not an int because what we pass here is really not an int. But if we change this to be float, and we're going to say 22.2f is a float, we're going to change our message here is not a float. That's what we're going to say here. We expect this to hit the block here because 22.2f is a float literal based on what we know already. So we are going to pass this through our GCC compiler. Build is going to be good. We're going to clear and run rooster, and we're going to see that this is a float that we are dealing with here. You can also print the type directly. For example, we can say stdc out type id int, and we're going to print this out directly. We can do this. And the syntax to do this is type id, and we're going to say int, and we're going to call the name method on this. This is going to give us a printable name. We can print and debug what is going on in our inheritance hierarchy. So if we do this, this is going to give us a representation of the int type in the eyes of the compiler. Let's build and run and see this. We're going to pass this through GCC. The build is going to go through. If we clear and run rooster, we're going to see that type ID for int is I. And this is going to be different based on which compiler you use. For example, we just used the GCC compiler, but we have the luxury to try out different compilers in our Visual Studio Code editor. We can try and use the Clang compiler. Let's do that. We're going to build again, and we are going to get a bunch of errors. What is the problem here? What is the problem with Clang? Let's look at what we have in here. We will have our rooster PDB file. Let's remove it, or we can remove it from the left sidebar here. This is going to be much better. So we can hit right click and delete. We're going to delete this file here, and we're going to build with GCC again to make sure that we have no problem. Let's run this through GCC. This is going to build fine, and if we clear and run, we're going to see our type printed out here. Let's use the compiler from Microsoft. We can use that. We have it available here. We're going to wait for it to finish its thing. And the build is finished. Good. We can clear and run rooster. We're going to see that the type ID now is int. It's no longer I like we saw with GCC. I don't really know what is wrong with Clang at this moment. And we're going to pass this through Clang again. Let's try this out. We're going to use Clang 11. We're going to call our Clang compiler. Let's see what we are calling. So we are going to ignore this for a moment, and we will explore this later. But the point I wanted to make is that each compiler is going to have a different representation for types that you print through type ID. So don't expect to see the same thing if you are using different compilers here. Now that we have tried this with fundamental types, we're going to try and do this using our polymorphic inheritance hierarchy. We are going to put in a piece of code to do that. So we are going to be using type ID with references with our polymorphic inheritance hierarchy. We're going to set up a dynamic derived object, and we're going to be referencing that through a base reference. And we will try to print out the type ID of dynamic derived and base ref, and we're going to see what we get here. We can pass this through GCC, our favorite compiler. This is going to build successfully. We can clear and run rooster. Now that we have this, we're going to see that type of dynamic derived is the 14 dynamic derived. And if we ask our base reference what it is currently referencing, it is going to tell us I am referencing a dynamic derived object. And hopefully you can see that this is super useful if you are debugging your code and asking your base pointers or references what they are referencing in your polymorphic inheritance hierarchy. This is really cool. We can also do this using pointers. We're going to set up a simple example of using type ID with pointers on our polymorphic inheritance hierarchy. We're going to set up dynamic base. It is a base pointer which is going to be managing a derived object. A classic setup for polymorphism. We're going to print out the type ID of our pointer, and this is going to give us a static type. And in other words, it is just going to give us the type of this base pointer, and that's not what we want. If we want to get a dynamic type or a type that is referenced through polymorphism, we need to dereference the pointer and then call the name method on type ID here. This is going to give us our dynamic type. Let's build and run and see this in action. We're going to pass this through GCC. The build is going to be good. We can clear and run rooster. And we need a separator to make sure we see these things as clearly as we can. We are going to go down here and put in our separator, and we're going to build again. The build is good. We can clear and run rooster. Now we're going to have our separator, and we're going to see that the type ID of BPTR, which is what we have on top here, the type of that is going to be dynamic base, as you see here. And hopefully you can see that this is a static type because it is the type of the base pointer here, classic static binding. But if we dereference the pointer, we're going to get our dynamic type here, and this is probably what we want. We can also use our type ID on our non-polymorphic inheritance hierarchy, and we expect this to give us static binding results because we don't have any virtual function in that inheritance hierarchy. If we print the type of this base pointer, we're going to get the base class. That's what we expect to see printed out here. If we print the type of this base reference, we expect to see the base class printed out because we don't have polymorphism going on in our non-polymorphic inheritance hierarchy here. Again, if we go here, you see we don't have any virtual function. So this is going to do static binding. Let's build and see what we get. We're going to pass this through GCC, our favorite compiler. The build is going to be good. We can clear and run rooster. And at the end, we need a separator. Let's grab this. We're going to copy this and put that in front of what we just did here. Because we need to make this super easy to follow, we are going to build again to see our code that we just added in here. And the build is good. We can clear and run rooster. And we're going to see that with our non-polymorphic inheritance hierarchy, we will only get static binding results. If we print the type ID of each base pointer or reference, we're going to get the base class. And this is classic static binding in action. This is really all I had to share in this lecture, showing you that you can use the type ID operator to ask a base pointer or a base reference the derived type it is currently referencing or pointing to. And this is really good, especially if you want to debug your polymorphic code. We are going to do what any good C++ citizen is going to do. You notice we are using the new operator to allocate space for bptrs here. I think if we go on top, we're going to see another dynamic memory allocation. We need to release this memory. So we're going to do delete bptr, and we're going to delete bptr, and we're going to release what we allocated here. This is going to be good, and it is going to properly release our memory. We don't want to be leaking memory in our C++ application. Let's build and see that this is actually building just fine. The build is going to be good. We can clear and run rooster, and this is going to give us what we have seen before. This is all good and fine. We are going to stop here in this lecture. In the next one, we're going to learn about pure virtual functions and abstract classes. Go ahead and finish up here and meet me there.